On this video, I'm going to show you how you go about identifying from the image which law of motion is being represented and what kind of key features you should be looking for on it. So in this picture here, look at it as a time sequence, such as this is like a time 1 and this would be a time 2. Here you've got a person sitting in a car, they have their nice little seatbelt on, and all of a sudden you have the brake put on. And the car stops, but the person is moving forward. And of course, when you're in motion, you want to stay in motion. So it's that key thing that motion equals staying in motion. What's happening then is we have inertia. And inertia, of course, is an example of the first law of motion. So this picture here would be the first law of motion. Okay, in this picture here, we have some guy, and he is pushing a bus full of kids. Anytime you see a push or a pull, could be a pull, that means we have a force being applied, because that's the definition of a force, any push or pull that results in motion. So he's trying to get this bus to move in that direction. So that's clearly a second law example. And remember, the second law deals with forces. We have an equation. Force is equal to mass times acceleration. But that's a second law example. In this one, it says, in the caption, it says, when you push back on the water with the oar, the water pushes back on you. Well, anytime one thing goes one direction and you have something going the opposite direction, we have an action-reaction scenario. And that would be our third law of motion. In this one here, this is a really interesting one. Guy's riding a motorcycle here. All of a sudden the motorcycle comes to a stop because it hits the wall. And what happens to the guy? He goes flying forward. So because he was on the motorcycle and the motorcycle was in motion, he wants to stay in motion, especially since he's not attached to the motorcycle with any kind of seatbelt safety device. So his own inertia is propelling him forward, and that would be a first law example. On this one here, we have two balls. They look equal, so they probably have the same mass. Remember, arrows represent force in our little diagram. And so this arrow looks like it is pushing. Any push or pull. And then this probably is a direction. So large force, this one would be large. This would be small. And it doesn't move as far. This one moves farther. So anytime you have a force involved, you're talking second law. This one should have been a freebie because they talk about reaction, action. One goes one way, one goes the other. That's clearly the third law. You can see here as this person pushes forward, it's going back. And then the famous one, Sheldon and Newton. Here's Sheldon, and the question was, who's going to hit the cake with the most force? So Sheldon, he's moving slow. He has a mass of 20 kilograms, and his change in speed is 5 meters per second squared. Whereas Newton, over here, he's moving fast. He has a mass of only 5 kilograms and an acceleration of 20 meters per second squared. And we want to know force. So we know from our equation note card that force is equal to mass times acceleration. If we figure this one out, we've got 20 kilograms times 5 meters per second squared. That would equal a force of 100 newtons. And Newton down here, the same thing. If I figure out what force he's going to hit with just mathematically, I've got 5 kilograms times 20 meters per second squared, and he also hits at a force of 100 newtons. Because remember, force is a combination of mass and acceleration. So they're both going to hit with the same force. It's not the fat one's going to hit with more force or the skinny one moving faster is going to hit. Mathematically, they're both hitting with 100 newtons of force. So this was kind of a tricky one. Only a few people got this one right because they took the time to figure out mathematically what was going on here. So that's how you figure out which law of motion is happening based upon the representation. It's kind of like the lab you just did. I hope this helps.